Hello, pre-algebra students. Mr. Lawrence here with your flipped lesson. And today we're going to move into some real algebra stuff. We're going to be in algebra all quarter, getting you ready for next year. And this is very important to your reasoning. Now, I got to promise you, this will be easy if you stay up on your work. If you don't stay up on your work, this will be a very, very sad quarter for you. All right, first of all, these are all one-step equations. You see them here? We'll call them equation A, B, C, and D. And we're just going to briefly remember how to solve these. Well, remember we're going to use the inverse operation. We're going to use the inverse operation to help us solve. Now we're going to be doing more complex stuff than this, but this is just a little warm-up. Tell you what, why don't you solve those four and see if you can get them right, and then I will show you my solutions. Okay, so in problem A, I see that I have a 2 next to an x. I know that's multiplication, right? And so to undo multiplication, I'm going to divide. And notice I didn't use a division symbol. I'm going to strongly encourage you to not use a division symbol, to use a fraction bar. It's a technique that I use, and it is very successful. 10 divided by 2 is 5. And there you go. Hopefully you got that one right. Now B throws kids for a loop sometimes, but it's just a multiplication, or excuse me, it's just a division problem. X over 4 equals 2. So to undo that, to use the inverse operation, I'm going to multiply by 4 on both sides. When I multiply by 4 on the left-hand side, though, I'm going to write a special form of 4. It's 4 over 1. No, not for breakfast. Go see Mommy. She'll get you some food. Hurry up, she's going to leave because she's got to go to work. Okay, sorry about that. My son was talking to me really quick. And so what happens on the right-hand side, I get 8. The left-hand side is actually even easier. The 4's cancel each other out. Why? Because 4 divided by 4 equals 1. So I get x equals 8. All right, see, I have a 5 attached to the x by subtraction. I'll add 5 to both sides, and I will get x equals 17. And then on this one, I have a 2 attached by addition, so I will subtract on both sides and get x is equal to 4. Now, the smart person will check their work. They'll put the 4 in for x, and see that 4 plus 2 does equal 6. It checks. They got the right answer. I'll put the 17 in for x on problem C. 17 minus 5, yep, that's 12. They'll put the 8 in for x. Get 8 over 4. What's 8 divided by 4? Well, my gosh, it's 2. And then on this one, they'll do 2 times 5, and they'll get 10, and they know it checks. All right, so how do we handle two-step equations? Because that's what we're going to be focusing on. The one step was just a warm-up. You guys should have already mastered that last year. How do we focus on two-step equations? How do we do a problem like this? Well, I use a series of questions. And my first question is, what is my goal? And of course, your goal is to get x alone, or get the variable alone, right? Okay, so then the follow-up is, what numbers are keeping x from being alone? And in this case, the answer to that question, problem number 1, are the 2 and the 5, right? All right, so then I ask myself the third question, how are they attached to x? How are they attached? Well, I'm asking what operations are they attached by? The 2 is attached by multiplication. The 5 is attached by addition. How do I know? The 5's positive. Number next to a letter for the 2 means multiply, right? Okay, well then I ask myself, how do I undo those? Well, to undo multiplication, I'm going to divide. I'm going to use the inverse operation. To undo addition, I'm going to undo it with subtraction. Okay, now the last question I ask myself is, which do I undo first? And that's an easy one. I listen to Saddam. Saddam tells me to undo subtraction and addition before I undo division and multiplication. All right, so let's go to problem number one. I've got the 2 and the 5. The 2 is attached by multiplication. The 5 is attached by addition. I need to undo the addition first because Saddam told me so. So to undo addition, I'm going to subtract. I'm going to subtract this amount, 5. But if I do it to one side, I've got to do it to the other. And my new equation turns into 2x equals 2. And now I have just a one-step equation. All I have to do is undo the multiplication by division. I'll divide by that number right there. And when I do that on both sides, I will get the answer x equals 1. Now, if I come up here and plug the 1 in for x, do a little check. 2 times 1 plus 5, 2 plus 5 does equal 7. Okay, so problem number 2. Go through our questions. What is a goal? To get x alone. What numbers are keeping the x from being alone? Well, there's a negative 3 and a 4. How's the 4 attached? By addition. How is the negative 3 attached? By multiplication. So, to undo those, I'm going to use subtraction and division, and I'm going to listen to Saddam. Saddam's going to tell me to undo the addition first. So I'm going to subtract 4 from both sides, and then I'm going to get negative 3x equals 24. I'm down to a one-step equation. I have to undo this multiplication. I'm going to divide. And this is so easy because you see the negative 3 there? That's what I divide by on both sides. Okay. Now you guys are too old to get this problem wrong. First of all, you know that 24 divided by 3 is 8. So if I introduce a negative, then doesn't that have to change the value of the problem? So I'm going to get a negative 8 here. You're not allowed to get that wrong anymore. You're too smart to get that wrong. If I check it, I stick negative 8 in here for x. Negative 3 times negative 8 is a positive 24. Plus this 4 gives me 28. I know my answer checks. All right, let's try number 3. What's my goal? To get x alone. What numbers are keeping x from being alone? This time I have a negative 3 here, and I have a 4 here. How are they attached? The negative 3 by subtraction, the 4 by division. How do I undo the division? Oh, multiplication. How do I undo the subtraction? By addition. And which one do I undo first? Well, I undo according to Saddam. So I'm going to undo the subtraction first. So I'm going to add 3 to both sides. And I'm going to get x over 4 equals 13. And then I'm going to use multiplication to get rid of the division. And I'll multiply by 4 on the right-hand side and by 4 over 1 on the left-hand side. Now, I'm not kidding. The left-hand side is easiest because 4 over 4 cancels out to plain old x. 13 times 4, if I double 13, I get 26. If I double that, I get 52. 13 times 4 must be 52. And there you go. All right, last problem here. I've got division, right? Negative 2 is attached by division. And I've got an 8 attached by addition. And to undo the addition, I'm going to subtract. To undo the division, I'm going to multiply. And Saddam is going to tell me to undo the addition first. So I will subtract 8 from both sides, and I will be left with 22, and the left-hand side is x over negative 2. Now, to get rid of this negative 2, it's division here, I need to multiply. Since it's a fraction, I'll write my multiplication as a fraction. And I'll multiply by negative 2 here. All right, the right-hand side will become negative 44. The left-hand side, again, is the easy side. The negative 2 and negative 2 cancel out, leaving just an x. And there you go. If I check it, negative 44 divided by negative 2 equals 22. And 22 plus 8 does equal 30. I'm good as gold. All right, that's your lesson for today. If you need to rewatch it, go ahead and do that. Mr. Lawrence signing off. Good night, everybody.